Concept we're covering now is something called special right triangles. There are two special right triangles. The first one we're going to focus in on is the 45, 45, 90 right triangle. What we have here is two angles that are 45 degrees, and the third is 90. That's the name. It's also called an isosceles right triangle because the two legs are going to be the same thing. So in this case, they're both x, whatever x is. The pattern that will always follow here is that the hypotenuse will be whatever the legs are times the square root of 2. So this is not really computational math as much as it's recognizing a pattern and being able to apply it to all of these shapes. So again, we're focusing on just this first one here. Let's see some examples. First problem, I identify a right angle and a 45-degree angle, so I can solve and figure out that this other angle is 45 degrees. I know it's a 45, 45, 90, so I'm good to use the pattern I described. What we call this is the isosceles right triangle, which means the two legs have to be exactly the same. So if one leg is 8, the other leg has to also be 8. Done. Great. Now the two legs are the same, and the hypotenuse is whatever the leg is, which is 8, times the square root of 2. Okay? So no matter what those legs are, you multiply by the square root of 2, and you get the hypotenuse. Those two, 8 root 2 doesn't multiply together because it's a coefficient and a radical. So your answer is just 8 root 2. Simple as that, right? Again, not requiring a whole lot of computation, but just recognizing patterns. Second one, let's apply it. So it is this time giving us the hypotenuse. The hypotenuse is 5 root 2, and the two legs are equal with a 90-degree angle. So again, I can identify this as a 45, 45, 90 right triangle or an isosceles right triangle, which means the two legs would be exactly the same. In the first problem, we took the leg length and multiplied by root 2 to get the hypotenuse. Here, we're doing the opposite. I'm going to take the hypotenuse and divide it by root 2, because when you go from the hypotenuse to the leg, you divide, as opposed to multiply. When you divide that by root 2, those simply just cancel out, and you're left with 5. Therefore, both legs are 5, and I'm done. Check back at the end and always see, does it follow that pattern that the legs are the same? The hypotenuse is that times root 2? It does. Cool. The third one has a little trap in it, so don't fall into it. Here I'm given, again, a right angle, and the two legs are exactly the same, so I can deduce that it's a 45, 45, 90. And means it follows the same pattern. Two legs are the same. The hypotenuse is always the leg times root 2. Look back to our first problem. To find the hypotenuse, I took the leg times the square root of 2. Do the same thing here. Just because there's a root 2 already on it, that doesn't matter. That's okay. So 5 root 2 is the length of the leg. To find the length of the hypotenuse, I multiply that by root 2. Might look weird at first, but that's okay. Multiplying the radicals together, the radicands together, I would get 5 times the square root of 4, because 2 times 2 is 4. Square root of 4 is 2, so 5 times 2 is 10. And that's your hypotenuse. That's how you use the 45, 45, 90 to solve right triangles.